Good evening, everyone. Welcome to NEPM 2021, organized by Department of Mathematics, Sacred Heart College, Chalakudy. And today is our 9th day of 10-day enrichment program. So I invite Ms. Adiravi, Faculty of Department of Mathematics, Sacred Heart College, Chalakudy, to the formal introduction of today's resource person.
Good evening, everyone. I have great pleasure to welcome today's resource person, Ms. Amala Mary George, Assistant Professor, Department of Mathematics, Sacred Heart College, Chalakudy. She has completed her undergraduation from Bharat Mada College, Ernakulam, post-graduation from St. Albert's College, Ernakulam, and MPhil from University College, Trivandrum. Her interested areas in mathematics are operation research, functional analysis, and discrete mathematics. In today's session, she will talk about interesting concept in linear programming. Once again, welcome you ma'am to NEPM 2021, organized by Department of Mathematics, Sacred Heart College, Chalakudy.
Welcome all to this pleasant evening. Hope you're all healthy and safe. First of all, thank you Adira for introducing myself in such a beautiful way. I'm really proud to be a part of NEPM 2021. Last year also we had conducted the same program and it was a great success. It actually provides a platform for mathematics lovers, so to just learn and have some fun in maths or just learn something new about the subject. Mathematics is around us everywhere. Wherever you look, you can find a maths in it. And I would tell, or I can guarantee all those who have graduated in maths or is yet to graduate in mathematics, I can assure you guys that you have the key to open many doors. Okay, there is a wide range of opportunities for degree holders in mathematics. They can pursue MSc mathematics, they can go for analytics, they can go for actuarial science. Many options are there, and all this is possible just because of the subject mathematics. So in today's lecture, I'm just gonna deal about a concept called the linear programming problem. I'm pretty much sure that many of you must have dealt with the same during your 12th class, and you guys must have done or solved mathematical models using graphical method. That is, we just had two unknowns and we had to solve, or we had to find a solution which will maximize or minimize a particular function subject to various constraints. So you must have solved the linear programming problem with the help of graphical method. In daily life problems, there will be more than two unknowns which we'll have to solve. So we introduce the new method, and also we'll be discussing two types of linear programming problem. But just moving on, or just before going into the problem section, it will be nice if we could understand, or if we could learn why did this come into existence, or how did this come into existence, and what is actually LPP, and so on. So I'll move on to my presentation right now. So first of all, the question that we are going to ask is, what is LPP? LPP, as you all know, is a short form of linear programming problem. So what is LPP? It is actually a process which takes into consideration certain linear relationships, okay, to obtain the best possible solution. Okay, we are considering various linear relationship to obtain the solution of that particular problem, and it is very helpful. It is a great tool for developing and solving a decision making problem. So many decision making problems can be solved using LPP. And as it suggests, we can use it, or it can be guided for quantitative decisions. Okay, so keep in mind the words quantitative decision in business planning, in industrial engineering, and to a lesser extent in social and physical sciences. So this is actually a quality of linear programming problem, and this is the actual definition or the concept of linear programming problem. We can formulate linear relationships to solve a mathematical model. Okay, let's now just take a sneak peek into the past. So in 1939, the economist Leonard Kantrovich, he formulated a linear programming problem and also proposed a method to solve it. And what made him do it? It is a way he found during World War II to plan expenditure and returns in order to reduce the cost of the army and to increase losses to the enemy. And in year 1941, Frank Loren Hitchcock formulated the transportation problem. We'll be discussing about it, which is another linear programming problem, and also provided a solution very similar to that of Simplex Method. Okay. Then, in the year 1946 to 47, the works of John B. Tansing was developed, and he could develop general linear programming formulation. Okay, and he did so because for planning problems in US Air Force. So again, there is something related to military and all. So he invented a simplex method which for the first time could solve most of the LPP. And because of that, he is also called as the father of linear programming problem. And even during the post-war period, many industries applied it in their daily planning. Now, as Indians, we should not forget to mention the contribution of an Indian mathematician, Narendra Karmakar. He introduced an interior point method for solving the linear programming problem, and the discussion of whether interior point method is better or simplex method is better is going on, and it actually brought about a theoretical and practical breakthrough in the same field. So this was a little bit about the history of linear programming problem. Now, why should we learn this? Why should LPP be learned by any one of us? So the answer lies in its applications. So first of all, in agricultural planning, it has an application as it helps the farmers in allocation of limited resources such as acreage, labor, water supply, and working capital, and much more, in a way so as to maximize the net revenue. Okay, so this is applied in most of the agriculture work, in field work, in harvesting, in the livestock and everything. We apply LPP so as to solve many problems faced by the farmers. Next, in military applications, as we have seen in history itself, the LPP was applied in US Air Force and military and all. The same is applicable for determining the number of defense units that should be used in a given attack in order to provide required level of protection at the minimum possible cost. Okay, or it also includes like problem of selecting an air weapon against our enemy so as we won't be attacked by enemy or the enemy will be laying dominant, and which includes the consumption or minimizing the amount of the aviation gasoline which is used. So you can see that it has applications in military also, in Air Force also. And the next comes in marketing management. In marketing management, it helps in determining the most economic and efficient manner of locating manufacturing plants and distribution centers for physical distribution and so on. So suppose if you are having a business of some product, say P1, and we want to sell it, and we nowadays social media is on its peak due to the pandemic. Also, we are all sitting at home and always looking at the phone. So the business, as a business person, we can improve or promote our sale using social medias, but the same thing won't be possible in remote areas where the network availability is not as much, so we have to use some other marketing material. So these all can be tackled with the help of linear programming problems. Next is in personal management. We all do not have the same ability to do a particular job. One person must be good in one job, the other must be good in another job. So in personal management, it is used to allocate optimum manpower to a particular job so as to minimize the time or cost. Okay, and it helps in the selection of a particular person for a specified job. So it helps a lot in personal management. In some way or the other, we all are performing this in our day-to-day life. The next one application is in production management. It also helps to determine what product must be produced, or it helps in production plan and depending upon the demand. Also, a particular product can be manufactured with the help of different raw materials. Okay, so it helps, a linear program helps in understanding which raw material must be used to produce the product in order to minimize the cost. So many questions can be solved with the help of linear programming problem. So these are almost a few applications of linear programming problem in day-to-day life. Next, as there is good and bad in all of us, similarly there are advantages and disadvantages of LPP. First we'll move on to the advantages. It is as we have mentioned so far in previous slides and all, it helps in the attainment of optimum use of productive resources, and it helps in decision making. It provides practical solutions, and it helps in reevaluation of a basic plan for changing conditions. Now, apart from all these advantages and applications, it has a few disadvantages which we have to consider. Because the first one is the objective which must be included must be identified. The variables and the objectives which we must include in our problem must be identified, and that will be a little bit difficult. It wouldn't be easy in all the cases. The next disadvantage, or the main disadvantage, is that the data which must be entered must be in quantitative measure. Okay, for example, if I have a particular person who is apt for a particular job and he gives me a result in minimum time, what happens one day if he gets sick? His performance will be decreased. Okay, and that will increase the time of production of that product. But that particular change cannot be measured because it's not a quantitative measure, and that cannot be done with the help of LPP. The next one is the availability of non-integer solution. Okay, in some cases when we solve the mathematical problem using various methods, we can get non-integer solutions, and that is not acceptable by us, because for example, if I have to calculate the number of chairs and tables that I need to minimize my cost, and if I get an answer like half, that is not possible. I can't go to a shop and say I want half a chair. That is not a possible solution. So that is a great disadvantage of LPP. And it also we won't be able to deal with multi objectives. That is also not possible for a case of LPP. So these are the disadvantages of linear programming problem. Now let us now begin with the problem section. So as I had mentioned, we shall be introducing a method to solve the linear programming problem, which is called as the simplex method. Now in a simplex method, we will be given a problem either to maximize or minimize a particular function. Okay, and this method is mainly used to solve most of the LPPs. Okay, and the problem which will be given to us will be in the canonical form, and we'll have to convert it into standard form and then solve using the simplex method. So now I think we shall move on to the problem. I'll give a brief example, a simple example which we can work out together. So maybe most of you must be familiar with this method. For those who are familiar, you can just consider this as a revision, and for those who are not, you can take a pen and paper and move along with me. So first we shall be discussing about simplex method, that is how to solve the problem. Okay, the problem that I'm considering is to maximize, that is maximize the function. What should I maximize? I should maximize 12x1 plus 16x2. So this also contains, I'm taking a simple example to make you guys understand. So this same problem consists of only two variables, so you can do it with the help of graph also, but let's try out the simplex method for this problem. Subject to the constraint, this is the short form that I'm using, subject to the constraint 10x1 plus 20x2 is less than or equal to 120. 8x1 plus 8x2 is less than or equal to 80. x1 is greater than equal to 0, x2 is greater than equal to 0. So this is a problem which is given to us, that is to maximize the given function. Now the problem which is given to us is in the canonical form. This is called the canonical form. Okay, so to proceed with simplex method, what we have to do is first we have to convert it into the standard form. Okay, to standard form. So how can we do that? I will for conversion to standard form, I have to remove all these inequalities. So the problem will be maximize z is equal to 12x1 plus 16x2 subject to the constraint 10x1 plus 20x2 is plus I am adding one variable which is called as a slack variable, which will give me the equality, okay, which will convert the inequality to equality, and 8x1 plus 8x2 plus another variable s2 which is equal to 18. Now I'm introducing two new slack variables s1 and s2, so I have to introduce them in our objective function also. Okay, and our objective was to maximize the function z is equal to 12x1 plus 16x2. So I have to introduce these variables, but I should keep in mind that the variables which I am introducing should not affect my objectivity. Okay, so what can I do? I can put the coefficients of these variables as 0 in the objective function. Okay, and all these variables must be greater than or equal to 0. x1 greater than equal to 0, x2 greater than equal to 0, s1 greater than equal to 0, and s2 greater than equal to 0. So this is my standard form. Okay, so once I get a problem, I'll convert it into the standard form. Now for people, for those who are not able to just keep or grasp or get an idea of this particular problem, I'll give you a simple example. Say now it's due to this pandemic, we are all getting bored sitting at home doing nothing, okay, apart from looking into our phone, and the students looking into their computer and learning something online. Everything is online, so I'm completely bored and I am planning to host a party, okay, but according to the government rules of COVID. So the maximum person party, in the sense I'm just inviting my family's very close friends, okay, and I'm planning to provide them with biryani, say, as food. Okay, the cost of one biryani is like, for veg it is 100 rupees, and for a non-veg I have the cost is like, say, rupees 120. Okay, and due to the same pandemic I have very less money with me, so my main aim is to minimize the cost and conduct the party. Okay, so I can convert this into the linear programming problem. How can I do that? I have to minimize the cost. The cost will be like, say I'm denoting V for the people who are having veg and N for people who are having non-veg. So I have to minimize Z is equal to 100 into V plus 120 into N, right? So this V and N is the number of people who are having veg and number of people who are having non-veg. So my main aim is to minimize the cost that I have to take and conduct the party. That is, I have to find how many people should I invite. Okay, and maximum the people who are having veg in my home or among my family and friends is, say, like between say 10 to 15. Okay, so it should be less than or equal to 15, and the maximum number of people who are having non-veg is, say, like between 20 to 25. So N should be less than or equal to 25, and both must be the sum V plus N should be less than or equal to 50. This is the like 50 people can hang over or get together according to the new regulations of the pandemic COVID, and both V and N should be greater than 0. So voila, I have a linear programming problem. So everything that is happening around us can be treated as a mathematical model. So this is the same thing that we have written here, that is we have to maximize some function subject to various constraints. I think so. I hope it is clear in your mind now. Let's move to the method of solving the linear programming problem with the help of simplex method. So for that we have to draw a table. Okay, this will be my first table, and what will be the table consisting of? I'll have the cost coefficient Cj, a column for the basic variable, a column for the value of basic variable, and the corresponding variables. What all do we have? We have x1, x2, s1 and s2, right? These are the values that we have. Now the basic variable here will be those variables whose values can be determined, that is s1 and s2. Now if you look at the standard form, okay, if you look at the standard form, you can see you have 2 equations and 4 variables, right? So to solve, in general case, when we are given 2 equations and 4 variables, what do? We just put arbitrary values for any 2 variables and find a solution. So the same thing we are doing. So in this case, if I put x1 and x2 0, I get the value of s1 and s2. So those will be my basic variables. Basic variables will be s1 and s2. And what are the coefficients of s1 and s2 in the objective function? It is nothing but 0. And what will be the value that I get? s1 will be equal to 120. When I put x1 and x2 0, I get s1 is equal to 120 and s2 is equal to 80. Now to fill the rest of the table, what I have to do? I have to put the coefficients of the constraints. In the first constraint, we have x1's coefficient is 10, 20, s1 is 1, s2 is 0. Next one is 8, 8, 0 and 1. Okay. Now I'll determine a quantity called as Zj, which is nothing but C1, this is C1 into x1 plus C2 into x1 2. Okay, that is 0 into 10 plus 0 into 8. In this case, everything value will be 0 because our coefficient Cj both are 0. So 0 into 20 plus 0 into 8 is 0. 0 into 1 plus 0 into 0, 0. 0 into 0 plus 0 into 1, again 0. Next, I will determine what is Cj minus Zj. What were the coefficients? I will just write it down here so that you guys won't forget. These are the coefficients in the objective function. Sorry, this is 12, 16, 0 and 0. Okay. So what will be Cj minus Zj? 12, 16, 0 and 0. Alright. Now for keep this in mind, for maximization problem, if Cj minus Zj are less than or equal to 0 for every j, then it means optimal solution is attained. Okay. So for maximization, optimal solution is attained if Cj minus Zj is greater than 0. And for minimization, what will it be? You can guess. It will be Cj minus Zj should greater than equal to 0 for every j. Okay. Then we obtain the optimal solution. So our problem is to maximize. So Cj minus Zj must be less than equal to 0. So in this case, you can see that none of our Cj's is less than 0. It is all greater than 0. So what we do? We choose the maximum among these. Okay. What is the maximum value? 60. This is the maximum value, and corresponding column will be our pivot column. Okay. This will be our pivot column, and this variable, that is x2, will be our entering variable. Alright, this will be the column corresponding to the maximum value of Cj minus Zj will be our pivot column. Okay, I can write this as pivot column. this is our pivot column, and the variable which will be entering into the basic variable value will be x2, that is the entering variable. Now we have to find what is the leaving variable, which one will be leaving, s1 or s2, any one of these will be leaving. For that we will determine a term ratio. How is the ratio determined? It is xj, the value of xj divided by the element in the pivot column. Okay, that is 120 divided by 20, which is equal to 6, and 80 divided by 8, which will be equal to 10. Yeah. Now to determine which is the leaving variable, I will choose the minimum among these. Okay, that is 6. So in ratio we have to choose the minimum, and in Cj minus Zj we have to choose the maximum. So this will be my leaving variable. Which is the leaving variable? S1. And so this one will be my pivot row. Okay, so I have got my pivot column and pivot row, and the element which is in the intersection of the pivot row and column is called as the pivot element. So here the pivot element is 20. Okay, so since I have not obtained my optimal solution, I have to construct the second table. Okay, this is a bit problem of the simplex method. You'll have to construct many tables, and thank God in my example there's just 3, but the number of tables can increase. So the table will be like Cj, the basic variables, xj, then the variables x1, x2, s1 and s2. Now let me write down the new table. For that we have to keep the table 1 in our mind. Okay, I need to make this element 1. Okay, so what will I do? I will divide the entire pivot row with 20. Okay, what will happen if I divide the entire pivot row with 20? I get 120 by 20, that is 6. This is 10 by 20, so I get 1 by 2, and I get 1 over here, so I have obtained 1. Okay, and this is 1 by 20, and this is 0 by 20 is 0, and the basic variable that is entering is x2, and the other variable is s2 itself. Okay, now what should I do is, the next thing I have to do is I have to make all the elements of the pivot column 0 except the pivot element. Okay, so the pivot element will be reduced to 1, pivot element is reduced to 1, and all other elements in the pivot column must be reduced to 0. Okay, so I have to make this 8 0. How can I make 8 0? What I'll do is I will multiply the row corresponding to the new basic variable x2. Row corresponding to the new basic variable, I'll multiply it by 8 and subtract it with the previous row corresponding to s2 in table 1, so that I get 0. That is, I have to multiply the row corresponding to the new basic variable with 8 and subtract it with the row corresponding to s2 in table 1. Okay, so I will get, I'll multiply this by 8. So what is 6 and 8? 48. So 80 minus 48, I get the value to be 32, and here I'll get 4, I'll get 0, and this is minus 2 by 5, and this is 1. Now the cost coefficients corresponding to x2 and s2 in the objective function is we have 16 and here we have 0. Now again we'll repeat the same process, that is, we'll determine what is Zj. Zj will be 16 into 1 by 2 plus 0 into 4. What will be the value? 16 into 1 by 2 is 8. Then we have 16 into 1 plus 0 into 0, that is 16 itself. Then 16 by 20 in plus 0 into minus 2 by 5. So we get the value to be 16 by 20, that is 4 by 5. Then 16 into 0 plus 0 into 1, that is 0. Next we determine Cj minus Zj and see whether all the values are negative or not, or less than 0. So what is Cj here? It is 12. 12 minus 8 is 4. 16 minus 16 is 0. then 4 by 4, 0 minus 4 by 5, that is minus 4 by 5, 0 minus 0, 0. So again we have one value which is positive, and what do we have to do? We have to choose maximum. So here there is only one value to choose, so that is 4, and so this will be our pivot column. And now we have to find which is the pivot row. For that we'll determine the ratio, that is xj divided by corresponding elements in the pivot column. So 6 divided by 1 by 2, which will give out to be 12, and 32 divided by 4, which gives out to be 8. So which is the minimum among these? What is the minimum? 8. So this will be our pivot row. And what will be our pivot element? 4, which lies in the intersection of the pivot row and pivot column. Now we have to construct another table, table 3, and in that table I have to make the pivot element 1, right? So we have Cj, we have basic variable, the value of the basic variable, and the variables x1, x2, s1 and s2. The basic variable is x2, and instead of s2 we have x1. Okay, and what is the cost coefficients corresponding to x2 and x1? It is 16 and 12. Now let's see what will be the value. For obtaining the pivot element 1 to reducing it to 1, I have to divide the entire elements of the pivot row by 4. So I have to divide this row by 4. What will be the value? Our value will be 8. Then we'll have 4 divided by 4 is 1, 0 is 0, and minus 2 by 5 divided by 4, that is minus 2 by 20, or I can say minus 1 by 10, and this is 1 by 4. I have to make the element in the pivot column 0, so I have to make this element 0. So I don't have this. Okay. So for making this element 0, what should I do? I use the row pivot row corresponding to the new basic variable in the table 3. I multiply it by 1 by 2 and subtract the row corresponding to x2 in the previous table. Okay, so I multiply this row by 1 by 2 and subtract the previous row corresponding to x2 of table 2. So I'll get 1 by 2 minus 1 by 2, I'll get 0. Okay, so this term will be 0, and what will be 8 into 1 by 2, that is 6 minus 8 into 1 by 2. What will be the value? 6 minus 8 into 1 by 2 is 4, 6 minus 4 is 2, and corresponding to x2 we get 1 itself, and we have 1 by 20 minus of 2 by 20. So altogether we get the value to be 1 by 10, and corresponding to s2 we have 0 minus 1 by 2 into 1 by 4, that is 1 by 8, so I get minus 1 by 8. Okay. Now let's determine what is zj. 16 into 0 plus 12 into 1, that is 12. 16 into 1 plus 12 into 0, that is 16. Then 16 by 10 minus 12 by 12 into 2 by 20. Solving, I get that value to be 2 by 5, and 16 into minus 1 by 8 plus 12 into 1 by 4, the value is 1. Now let me determine what is Cj minus Zj. Cj corresponding to x1 is 12, 12 minus 12 0. Cj corresponding to x2 is 16, 16 minus 16 is 0. Corresponding value of Cj of s1 is 0, so 0 minus 2 by 5 is minus 2 by 5, and here it is minus 1. So I have got all Cj minus Zj to be less than or equal to 0, that is I have got an optimal solution. And what will be the solution? The solution will be x2, the corresponding values, that is x1 will be equal to 8 and x2 will be equal to 2. This is the optimal solution that I need to maximize the given objective function subject to the following constraint. Okay, so here we have obtained just 3 tables. Now the number of tables can increase depending upon the problem. Now a note that I can give you is that, or a tip that I can give, the values of the elements corresponding to the basic variables will always be 1 and 0. So if you see in table 1, the values in the columns of S1 and S2 is already 1, 0, 0, 1. That is identity matrix. X2 and S2, if you see, X2 is having 1 and 0, S2 is having 0, 1. So again an identity matrix. Now in the last table, if you see X2 and X1, that is 0, 1, 1, 0. Again a form of an identity matrix. Okay, so this is a way of identifying whether your calculations is correct or not. If the values of the columns of the basic variables does not have the values of 1 and 0 only, then there is some problem in the calculations that you have done. Okay, so this is how we use the simplex method to solve the LPP. Now the problem that I had considered was consisting of constraints which were only less than or equal to. Right now, if the constraints become greater than or equal to, if we have a greater than equal to constraint, then we prefer the bigger method. Okay, we can solve by simplex method. Actually, bigger method is just a modification of the simplex method, which helps to solve problems having greater than equal to constraints. Okay, we won't go into the bigger method. You'll learn it for those who are preferring to take their post graduation in mathematics. You will definitely learn bigger method. So for greater than equal to constraint, we prefer the bigger method. So this was how to solve the simplex method. Hope you guys have understood the method. Next we shall move on to the assignment problem. Assignment problem is another type of linear programming problem. As we have seen, it is the allocation of various resources to various activities on a one-to-one basis in such a way that the cost or time is minimized or the profit is maximized. Okay, these are the conditions that has to be satisfied, that is time is minimum or the profit is maximum. So that is, it's similar to like what person must choose which job, or what resource must be given with what activity, and so on. Now to solve the assignment problem, the method we use is Hungarian method. This is the most convenient method to solve this type of problem, and it was introduced or developed by the mathematician Harold Kuhn. Okay. Now there are two types of assignment problem. One is balanced, the other is unbalanced. In balanced, the number of rows will be equal to number of columns, and in unbalanced assignment problem, the number of rows will not be equal to number of columns. So we can make an unbalanced row balanced by just introducing some dummy rows and columns and making the number of rows and number of columns equal. Okay, you'll understand what am I talking about rows and columns when we do the problem. So let's move on to the problem. So let's solve an assignment problem using the Hungarian method. Okay. So as I had just mentioned in the simplex method solving and the example that we had done, that I was how I considered to contact a party and convert that problem of buying the biryani in minimum cost to LPP. Okay, so I'm just keeping that in mind, and what I want is, I want say like food items. I want starters, I want say juice, a particular type of juice. I want my lunch, say I'm gonna order biryani, and I want a dessert for sure. A party without dessert is empty. So these are the things that I want, and I have say like H1, H2, H3 and H4. I have 4 hotels, okay, almost nearby, and these hotels are famous for all these products, and they have different rates. Okay, so I have starters, juice, biryani and dessert for my party, and I need to obtain them from the hotels H1, H2 and H3 and H4. Now for each thing I have different time getting them from these different hotels. Okay, so I need to find the best possible manner to allocate the starters, juice, biryani or dessert to these hotels, 4 hotels that are nearby, so as my time of requirement is less. That is, I have to obtain these things, all these things from these hotels in minimum time as possible, because I have to conduct a party and I don't have time to waste. Okay, so this is my problem, and this is nothing but assignment problem. Okay, in what way can I assign, or in which hotel should I assign to buy the starters so that the time is less in H1, H2, H3 or H4, similarly for all the others. So I am going to draw a table corresponding to the assignment problem. Okay, now let me see. I have starter here, I need the juice, I need my biryani, and I need my dessert. Okay, and I have 4 hotels. H1, H2, H3 and H4. Okay, now let me say for starters it takes about, say, 5 minutes, and in H2 for starter it takes 3 minutes, 2 and 8. And for juice I'll take like 7 minutes in H1, 9 minutes in H2, 2 minutes in H3 and 6 minutes in H4. And for biryani it's like 6, 4, 5 and 7. Okay, love biryani in 6 minutes. Wow, that's just cool. Now dessert 5, 7, 7, 8. Okay, this is actually a assignment. This is a different assignment problem. I have made it into this form so that you guys can get to understand what is actually happening. So this is our assignment problem in tabular form. That is, I can obtain starter from H1 in 5 minutes, from H2 in 3 minutes, from H3 in 2 minutes, from H4 in 8 minutes, and so everything goes for juice, biryani and dessert. So which hotel should I choose for which item so that my time is minimum? Okay, so let's move on to the Hungarian method to solve the problem. So I'll just write down the table again. We have 5, 3, 2, 8, 7, 9, 2, 6, 6, 4, 5, 7, 5, 7, 7, 8. Okay, this is the table that I have. Now, in the first step of Hungarian method is row reduction and column reduction. Okay, row reduction and column reduction. So what is done in row reduction? In row reduction, what we do is we choose the least element in a particular row and subtract it with all other elements. Okay, so in this case my first row 5, 3, 2 and 8, what is the least element? That is 2. So I subtract all other elements of the row with 2. So what do I get? After row reduction of first row, I get 5 minus 2, that is 3. This is 1. 2 minus 2 is 0. 8 minus 2 is 6. Similarly, I do it for every row. In the second row, 7, 9, 2 and 6, which is the least element, 2. I subtract 2 with all other elements. 7 minus 2, 5. 9 minus 2, 7. 2 minus 2 is again 0. And 6 minus 2 is 4. Similarly, for the next 2 rows. So I get 2, 0, 1, 3 and 0, 2, 2 and 3. This is the table that I get after row reduction. Okay, this is after row reduction. In row reduction, we choose the least element in the row and subtract it with all other elements. Now next we perform column reduction. Same thing which will be done for each column. So in the first column, I choose the least element. What is it? It is 0. So I subtract 0 with all other elements. So I get the same elements itself, 3, 5, 2, 0. In the second column also 0. So I get 1, 7, 0 and 2, and 0, 0, 1, 2, and in the last column 3 is the least element, so I have to subtract it. So all other elements of the column with 3. 6 minus 3, 3, 1, 0, 0. So this is the table that I get after my column reduction. Okay. So the first thing that is done in the Hungarian method is row reduction and column reduction. Once we have done the column reduction and row reduction, what we need to do is we need to find, let me write the table again, 3, 5, 2, 0, 1, 7, 0, 2, 0, 0, 1, 2, 3, 1, 0, 0. This was a table that we had obtained after our column and row reduction. The next thing we need to do is we need to find minimum number of lines, vertical and horizontal, to cover all these zeros. So we have zeros in our table, right? So we need to cover all these zeros with minimum possible horizontal or vertical lines, and that is done with the help of row scanning and column scanning. Okay, right? So in row scanning, what we do is we check the row and see for the zeros. If there is a single zero in the first row, if you see there is single zero, so I square it, cut off that column with a vertical line. Okay, let's check the second row. We have 5, 7 and 1. 0 is cut off, so there is no zeros, I can skip it. Next row, 2, 0, 0, there is more than 1 0, I will again skip it. In the last row, 0, 2, 0, again more than 1 0, I will skip it. So in row scanning, you check each row. If there is a single zero, I square it and draw a vertical line of that particular column. And if there is no zeros or more than 1 0, I skip it. Now let's perform column scanning. In column scanning, I go for first column. There is a single zero, I square that zero, and in column scanning I draw a horizontal line. Okay, so in column scanning I choose a 0 and draw a horizontal line. So let's move on to the next column. 1, 7 and 0, there is a single 0, so I choose just 0 and I draw a horizontal line. So this is it. In the third, there is no third column. In fourth column there are no zeros, so I skip it. So you can see that all the zeros are covered with minimum number of horizontal and vertical lines. Okay, now to check the optimality condition. What is optimality condition? It is attained when the number of rows, okay, is equal to number of squared zeros. Number of squared zeros. Okay, so here how many rows do we have? We have 4 rows, and how many zeros are squared? 1, 2 and 3. So in this case the optimality is not attained. We have not obtained the optimal solution, so we have to move on to the next table. So how can we form the next table? For that we have to do 3 things. One is write the elements along the line as it is except the ones occurring in the intersecting points. Okay, so what will happen here? We'll have 0, 0, we won't write 1, we won't write 2 because they are occurring in the intersection, and we have 0 here, again 0 here, 1 0 here, 2, 2 and 0. Okay, then what do? We choose the least among the elements which are not striked out or which are not cut off in the table. So the elements which are not cut off are 3, 1, 3, 5, 7, 1. What is the least among them? It is 1. And what do? I subtract all the elements which are not cut off with 1, and the elements in the intersecting point I add 1. I add this element to the elements in the intersecting point, and I subtract the least element to all other elements which are not cut out. So 3 minus 1 is 2, 5 minus 1 is 4, 1 minus 1 0, 7 minus 1 is 6, and 3 minus 1 is 2, 1 minus 1 is again 0, and 1 plus 1 2, 2 plus 1 3. So this is our new table. Okay, so what all have we done? We did three things. One, we copied the elements lying along the line as it is. Then all the elements which are not cut off, I chose the least element and I subtracted it with all the elements which are not cut out, and I added the least element which I had got to the elements which are in the intersecting points. Okay, so the new elements, a new table is 2 0 0 0 2, 4 6 0 0, 2 0 2 0 0 2 3 0. Okay, so here this is our new table which consists of zeros. So we don't have to do the row reduction and column reduction. We start from our row scanning and column scanning. So let me perform row scanning and column scanning again. So in row scanning, what do? We check the first row. If there is a single zero, I square it, otherwise I leave that row. So in this case, first row has more than one zero, I will skip it. Second row also more than one zero, I skip it. Third row also more than one zero, I skip it. Fourth row also more than one zero, I skip it. So row scanning I can't perform immediately. Now let's see column scanning. So in the first column there is a single zero, so I am going to square that zero and I am drawing a horizontal line across it. Okay, next let me go to the second column. There are two zeros, so I'll skip it. In the third column again two zeros, I'm going to skip it. In the fourth column again two zeros, I'm going to skip it. Okay, so immediate row scanning and column scanning is done, and I have just cut off two zeros. Okay, there are many other zeros remaining in the table. So what I do is I'm going to perform row scanning again, and in the first row there are two zeros. I can choose any one of them. Okay, so I'm going to choose this particular zero and draw a vertical line across it. Okay, then I'll go to the next row. In the next row, what I'm going to do is we are going to perform a thing called as diagonal selection. That is, I'm going to choose, again there are two zeros, so I'm going to choose the zero which is diagonal to it. Okay, this will increase the optimality of the solution, and I'm going to draw a vertical line across it. Now let's move on to the third row. In third row, what do we have? We have 2 and 0. There is a single zero, so I'm gonna just square it and draw a vertical line across it. I hope you have got the point. In initial row scanning and column scanning, we could not cut out all the zeros, so I choose any one of the zeros. So in this case, there is an option of multiple optimal solution, right? I can get two optimal solutions. Why? Because first I had chosen this zero, and you guys can try it out. I'm not going to do it again, so you guys can try it with this zero chosen first. Okay, what will happen if I choose this zero? Then in the next row I'll have to choose this one, and the fourth one I'll be choosing this one. So what will be the different optimal solution? You guys can just verify it. So here, as you can see, all the zeros are cut off with minimum possible lines. Now let's see the optimality, that is number of rows must be equal to number of squared zeros. So number of rows is 4, and what are the number of squared zeros? 4. So we have obtained the optimal solution. Now what is the optimal solution? We had our hotels here, right? H1, I'm going to write it here only, I'm not going to write the table again. H3, H4, we had our starter, we had our juice, we had our biryani, and we had our dessert. So what I have to do is I have to assign the starters to H2. Okay, so when I go to H2, I can obtain my starter within how much minute? 3 minutes, and I can obtain my juice in 2 minutes. If I give to the third hotel, I can obtain my biryani in 7 minutes from hotel 4, and I can obtain my dessert from H1 in 5 minutes. So altogether, how many minutes will I take? I'll take like 17 minutes to obtain the entire food item. So this is the Hungarian method to obtain the optimal solution. Okay, the usual problem which will be given to us, assignment problem, will be of minimization, but if it is maximization, we can reduce it to minimization problem by choosing the largest element in the table and subtracting all other elements from it. So we get the table for corresponding to minimization. Okay, so the next type of problem that I would like to discuss with you guys is the transportation problem. So as the name suggests, it is a problem to transport goods from the source to the given destination with minimum transportation cost. How can we transport goods from the source to the given destination in minimum cost? Okay, this is the transportation problem. Now again, there are two types of transportation problem: balanced transportation problem and unbalanced. In case of balanced, the supply and demand will be equal. Okay, supply at the source will be equal to the demand at the destination, and in unbalanced, the supply will not be equal to the demand. So the example that we are going to consider is a balanced one, and for unbalanced problems, we can make it balanced again by adding dummy row and a dummy column to make a dummy supply or demand to make it balanced, and then solve the problem. Now there are different methods to obtain the initial feasible solution for the transportation problem, that is northwest corner method, least cost method, and Vogel approximation method. Transportation problem is again another type of linear programming problem itself. Okay, so as it is a linear programming problem, we can solve it by simplex method, but the method will be very lengthy and very tedious work. It will be a very tedious work. So that's why we have developed different methods to obtain the initial feasible solution. And I would like to point it out to you guys that these methods are used to find just the initial feasible solution. Okay, so I cannot obtain an optimal solution using these methods. So the optimum solution can be obtained after with the help of Modi method, or I would say UV method, or stepping stone. Modi method or stepping stone method. So I won't be discussing these methods because they're a little bit lengthy. So we will concentrate on obtaining the initial feasible solution in this lecture. So we have three methods: northwest corner method, least cost method, and Vogel approximation method. But among all these three, the best method or the best initial feasible solution is obtained using the Vogel approximation method. So we shall be doing an example of transportation problem to determine the initial feasible solution using Vogel approximation method. So let's move on to the example. Now again, I had let's go back to my party. I had ordered food from various hotels. Now these hotels, if you consider these hotels as destinations, say H1, H2, H3 and H4. Now all these hotels will require raw materials, right? They will require raw materials to prepare food. So I am saying I have raw material 1, 2 and 3. Okay, so this is the source and this is my destinations. Okay, now I'm going to draw the transportation table. Okay, the transportation table will consist of independent cells, okay. Now each hotel will have a particular demand for the raw materials, so this will be my demand, and each source has a particular supply amount of raw materials which can be supplied. So let me take it to be like 300, 400 and 500, and the demand is 250, 350, 400 and 200. So first thing, we are given 4 hotels and 4 supply source and their corresponding demand and supply, and we are also given the cost of supply of each unit. Okay, like say 3, 1, 7, 4, 2, 6, 5, 9, 8, 3, 3, 2. Okay, this is the cost per unit, that is per unit. For 1 unit of source 1 to go to H2 is rupees 3. Okay, go to H1, sorry. And similarly 1 unit of product 1 to go to H2 is rupees 1, and so on. So this is the cost per unit. Okay, and this is the corresponding supply of each source, and this is the demand of each hotels, and this is the basic transportation table consisting of cells. Now first thing that we do in Vogel approximation method, or in any method that we are going to prefer, we have to check whether the problem is balanced or not. For a problem to be balanced, the supply must be equal to the demand, right? So let's total out. The supply will give out to be 300 plus 400 plus 500, that is nothing but 1200, that is same as 250 plus 350 plus 400 plus 200. So supply is equal to demand, so the problem is balanced. Okay, all right. Now again in the transportation problem also, the preference is to minimize the cost. Okay, minimization. Now if the problem given to us is of maximization, what can we do? We can convert it to minimization by, again we'll choose the maximum cost and subtract all other costs from it. Okay, the same process as done in case of assignment problem. We'll choose the maximum cost that is present in the table, and we will subtract all other costs from it and reduce it into a problem of minimization. Okay, this is our preference, but we can convert any maximization problem into minimization problem. Okay, now let's move on to the Vogel approximation method. Now for that, what we need is find the penalties. Now how can we find the penalties? The penalties can be determined by choosing the least element and the next least element. I'm going to consider the first row. Okay, now there are the elements there present in the cells are 3, 1, 7 and 4. Among them least is 1 and the next least one is 3, and I find the difference between them. So what is it? 3 minus 1 is 2. So this is my penalty in the first row. Similarly, I'll perform it for all other rows. So what is the least element? 2, and the next least element is 5. So the difference is 3. So the penalty for the second row is 3. Now in the third row, the least element is 2 and the next least element is 3. So the penalty is 1. Similarly, I do it for column. I choose the least element and the next least element, and the difference 1. This is 2, 5 and 3. So again 2, 2 and 4, 2. Okay, so these are my row difference, and this is my column difference, and the entries are the penalties. Now among the penalties, what I do is I choose the maximum penalty. So here the maximum penalty is 3. So I choose this particular row and I see the least. We need minimum cost, right? So I choose the least element from that, that is 2. Okay, so I am going to consider this particular cell, and I can see the demand corresponding to that cell is 250 and the supply is 400. Which is the least among 400 and 250? It is 250. So I am going to give 250 over here. Okay, so the 250 is demand is fulfilled, and from supply the remaining will be like 150. Okay, and I cut off this particular column. Okay, because the demand is finished, so I don't have to consider this column again. Now again we'll repeat the same process, okay, till all the rows and columns are cut off. So again, let's find the row difference. Here the least element is 1, so you don't have to consider this column. Least element is 1 and the next least element is 4, so the difference comes out to be 3. Next, in this case 1, in this case 1. Column difference, I don't have to consider this column. The difference is 2, the difference is 2, the difference is 2. So what is the maximum among these penalties? 3 is the maximum among these penalties, so I'll have to choose this particular row, the first row, not to use this particular cell. Okay, among these cells in the particular first row, which is the least cost cell, it is 1, so I'll choose this cell. Now corresponding to this cell, I have a demand of 350 and a supply of 300, which is the least among them. That is, demand is 350 but the supply is 300. I can only give 300 units, so I cannot wait for my I cannot just stay adamant and say I need 350. The only supply that is provided is 300, so 300 units can be provided, so the remaining will be 50. So I will give 300 over to this, and this row will be cut off. What is cut off completely? That particular cells will all be cut out. Okay, again we'll use the same procedure. So this must be done till all the rows are and columns are cut off. Now in this row, which is the least element 5, the next element is 1, so I don't have to consider the first row. In the next row the penalty is 1, again in the next row the penalty is 1. I'll cut off this column. The difference 6 minus 3, that is 3, 2 and 9 minus 2, 7. So among these penalties the maximum is 7, so I have to consider this particular column. Okay, among these, which is the least cost cell, that is this cell. So in this cell, what is the supply? Supply is 500 and the demand corresponding is 200, so 200 is less. I just need 200, so I can give whole of 200 over here. So among 500 remaining is 300. Okay, so and what will happen, this particular column will be cut off because there's nothing demanding over there. Now let's consider again the row difference. 6 minus 5, I don't have to find the first row. 6 minus 5, that comes out 1, and this is 0, and here I don't have to consider this column. Again the difference is 3, here the difference is 2, I don't have to consider this column. The maximum among them is 3, so I have to choose this column, and the least among them is 3. So here I need 50, I can give 300, so I just need 50, so the remaining is 250, so I will give 50 over here. Okay, and which is cut off, this will be cut off. Then again I can find the row difference. Here row difference as such there is nothing, 5 and 3, and this column is cut, this column is cut, this is 2 and this is less. Among these the maximum is 5, so maximum penalty is 5, so corresponding to 5 I have to allocate it in this cell. The cell there is 150 supply and 400 demand, so 400 I can give only 150, so I'll provide with 150, and among this 250 will be remaining. Okay, and this row will be cut off. Now again the only thing remaining is 250 250 each, so 250 to this particular cell. Now all the cells have been, so my total cost will be, what will be my total cost? It will be like 1 into 300 plus 250 into 2 plus 150 into 5 plus 50 into 3 plus 250 into 3 plus 200 into 2, and altogether the cost is like 2850. So this is the minimum transportation cost of supplying the source to the particular hotels. Okay, so I hope this method is clear for you. I really hope that all of you were able to understand the steps to determine the solution of the various LPPs that we have discussed today. So that's it. Thank you. Stay safe and healthy.
So now we can wind up our section, and I invite Miss Nima Maria, Faculty of Department of Mathematics, Sacred Heart College, Chalakudy, to deliver word of thanks.
Good evening, everyone. We have successfully completed the 9th day of NEPM. A very heartfelt thanks to the resource person of the day and my colleague Ms. Amala Mary George for giving an amazing talk on linear programming. I would like to appreciate all the keen participants of the program. Finally, I would like to thank everyone who put effort for conducting this session. Thank you. Thank you, everyone.